Hello again. This is the continuation for the notes for assignment 19 for AIM. And in this video, I will be going over how to add and subtract rational expressions. So the basic process here is that you'll factor all denominators if possible. Then you'll find the LCD of all fractions. Then you'll multiply the fractions by the missing factors in the denominator, combine fractions, factor the numerator, and reduce if possible. Let's take a look at number 1. For example 1 here, we have 3 over 3x minus 5 minus 7 over x. Now most of the time with these adding and subtracting rational functions, the least common denominator here will just end up being the product of the two. And you can think of it like this. The LCD here will be x times 3x minus 5. And you can tell that this will be the denominator because you have or least common denominator, because you have a 3x minus 5 in one denominator and an x in the other. Now, why is it important to have both of these in the LCD? Because when you go back through and multiply the fractions by the missing factors in each denominator, you'll notice that that factor x is already in the denominator of this fraction, and the factor 3 minus x is in the denominator of this fraction. So when I say multiply fractions by missing factors in the least common denominator, what that's going to look like is this. I will multiply the first fraction by x over x, because x is what's missing in this first denominator. And I will multiply the second fraction by 3x minus 5 over 3x minus 5. Because the 3x minus 5 in this LCD is what's missing in this second denominator. Why do we do that? Well, in order to see that, I need to continue to the next step here. I think what I like is having the single variable be in front of a set of parentheses. So this first fraction will end up being 3x in the numerator, because we can just multiply the numerators together. And in the denominator, we will have x times 3x minus 5 minus 7 times 3x minus 5 all over x times 3x minus 5. And what you can see now is that each fraction has the same denominator, which means we can combine these fractions together. To combine these fractions, we just have to do a couple things here. We can combine the numerator to be 3x minus 7 times 3x minus 5. So this part here will all be in the numerator of our new fraction. And we can do that because each fraction has the common denominator. So we combined the fractions. The only thing that we have to do now is make sure that everything in the numerator is distributed and collected, and basically just simplify the numerator. So in the numerator, we have 3x minus 21x if you distribute the 7 plus 35, and that'll be all over x times 3x minus 5. And there's no need to distribute anything out or multiply or simplify the denominator. So let's see, equals, 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 there we go. And then we can combine the like terms in the numerator, giving us a negative 18x plus 35 all over x times 3x minus 5. And there goes the simplified version of this rational subtraction up here. And yeah, you want to check very quickly, and I didn't say anything because I know it doesn't factor, but the numerator here will not factor, so this will be the final answer. For example 2, I want to bring to your attention here that there are no denominators that need to be factored. I see 5x squared, and I see 2x. Fine, we don't need to factor any of those. But we still do have to find the LCD. And in this example, you'll notice that each denominator only has one term. That being said, you'll go through and find the LCD of the numbers, like you've done with, linear equations with rational coefficients. And then you'll find the LCD of the variables separately. So in this particular example, if you tried to find an LCD of 5 and 2, you would get 10. And whenever you're trying to find an LCD of a variable to some exponent, you always take the highest exponent on that variable. So this would be 10x squared. And I realize that maybe some of you realize that an x could be reduced here. Let's forget about that for a second, just to keep going with this example. So once you find the LCD, we have to figure out what is missing. So here we have LCD 10x squared. What do I need to multiply down into this denominator to make sure I get 10x squared? Well, we have an x squared already here. It looks like I just need to multiply the top and bottom here by 2, and we will end up with the LCD that we have over here. And in this denominator over here, it seems as though we need to multiply top and bottom by 5x. So if I multiply the 2 here by a 5, I'll end up with 10 in the denominator, and I need to multiply by another x to make sure I get the x squared that is over here. So top and bottom by 5x, we can multiply all this stuff out. So in the left fraction, or the first fraction, I'll have 2x over 10x squared. And just remember, I'm not canceling that for the sake of this example. And in this fraction, I'll have 5x times x minus 1 all over 10x squared. All right, so that being said, we can combine these fractions now. That means we will have 2x plus 5x times x minus 1 all over 10x squared. Let's see here. We can distribute the 5x. That'll give you 2x plus 5x squared minus 5x all over 10x squared. Combine terms, 5x squared, combine these two terms here. 5x squared minus 3x's all over 10x squared. Now with this example being almost all the way done, right, what did we do? We factored all the denominators if possible. We didn't need to do that here. We found the LCD of all the fractions, check. We multiplied the fractions by the missing factors in the denominator. 2 was missing here, 5x was missing here, cool. We combined the fractions, which involves, again, combining the numerators. Let's do this, there we go. And it becomes one fraction. We distributed and collected terms. The last step is factor the numerator and reduce if possible. So in this example, because I held off on doing it, we can factor an x out of this numerator. So this would equal x times 5x minus 3 all over 10x squared. And we can reduce an x in the numerator and denominator. leaving us with an answer of 5x minus 3 all over 10x. Very quickly, there are just a couple more examples here that I want to get through before I end this video. And I also want you to have a chance to practice these. So with example 3 over here, I think the LCD will be easy enough. This is very similar to example 1 that we did right above here. And then example 4 is the first and only example where we have to do that first step of making sure you factor the denominators. And I just want to go through a little bit of that with you so you can give that a shot on your own. So with example 4, you can see that there is an x squared plus 5x plus 6 in the denominator right here. And before you want to do anything else, you'll want to factor that. And it will factor into x plus 3, x plus 2. And then you can rewrite the entire expression with that factored denominator, like this. From here, you can see that you'll be able to find an LCD. And the whole point in factoring that first denominator, and factoring the denominators in general, is to notice that each denominator already has a factor of x plus 2. So when you come off to the side to find your LCD, you know x plus 2 will have to be something in your common denominator because it's already common to both denominators. But also this x plus 3 has to be part of your LCD. So what's really nice is that this denominator is already taken care of, and you just have to figure out what's missing in this denominator, multiply top and bottom here by that, and then continue toward an answer. So go ahead and pause the video, try these, and let's see if you get them right. All right, there's a lot on this page that wasn't there before. Let me go over it real quickly. So in this exercise here, there are 2 different denominators, and we need each of these denominators to be part of the LCD. So you'll multiply the first fraction by x plus 7 over x plus 7, the second fraction multiplied by x minus 3 over x minus 3. And so then individually each fraction will look like this, which we can then combine into one fraction with one of those denominators. And from there, you can multiply out x plus 1 times x plus 7 to get x squared plus 8x plus 7. You can also multiply out x minus 5 times x minus 3 to get x squared minus 8x plus 15. Then, since there's a subtraction happening here, you would need to distribute the negative sign to all of the terms after it. So it would become a negative x, a positive 8x, and a negative 15. And then from there, you can just combine like terms. There's an x squared here, and x squared here. You can combine those. There's an 8x here, and a positive 8x here. You can combine those, and you'll get 16x. And then a positive 7 minus 15 is a negative 8. And then from there, you can factor an 8 out of the numerator, and just to make sure nothing cancels and nothing does, so this will be your final answer here. Example 4, we have, we went over the LCD here. You have to make sure you're multiplying the second fraction in the numerator and denominator by x minus 3, or x plus 3, apologies. And because I started running out of space, I can bring up this idea here. Once you make this multiplication, you can smush it into one fraction right away. You don't have to write out separate fractions like I did here in all the other examples. just remember that when you do combine these two fractions by adding or subtracting, that there's only going to be one denominator. You don't write down x plus 3, x plus 2, x plus 3, x plus 2. You just write down the denominator once. Okay, from there you can distribute the 3x to the x plus 3 to get these two terms here. From there you can combine terms together, 3x squared, there are no other x squareds, 9x and 3x make 12x, and minus 2. And this polynomial here in the numerator and our answer for example 4 does not factor. All right, that's it. I wish you all a lot of luck in moving forward with assignment 19, and I'll see you next time.